Aloha, my name is Shelly, and I'm the Outreach Coordinator at Keck Observatory. Today, I'm going to show you how to use a paper tube from around your house and the materials from this kit to engineer one of the most important tools in astronomy, a spectroscope. Stars like our Sun are made up mostly of hydrogen and helium with small amounts of other elements, like oxygen, sodium, iron, and calcium. But how do astronomers know this? They can't touch, smell, or weigh stars, so how do they know? Each element in our periodic table has a unique spectrum or fingerprint, and astronomers use spectroscopes, like the one you're going to build today, to study the many different fingerprints found in each star. The materials in your packet include a diffraction grating. Try to handle this card only by the edges and don't touch this film here in the center. You'll also have some tape in your packet. This is black tape, and I find that works better than Scotch tape, so I've given you some of this. And then also there will be a spectrum card in your packet. This will help you identify some of the spectra that you'll be looking at once you finish your project. From home, you're going to need a cardboard tube. This can either be a toilet paper tube. I really like these gift wrap tubes. They're really long. And a paper towel tube will work as well. So any kind of cardboard tube you can find around the house will be great. You'll notice that when you look at your diffraction grating, you might see a rainbow. The reason is that there are thousands of lines or grooves per millimeter, and these grooves help to spread out the light that's being reflected into wavelengths or different colors, and this spread out light is called a spectrum. Every element, like oxygen, hydrogen, and helium, have unique fingerprints or signatures, and that's what helps astronomers identify what a star is made out of. The more elements a star has, the more complex the spectrum. On the spectrum card in your kit, you can see how the spectrum of our Sun is different from a fluorescent light and a street light at night. It's also important to remember to never look directly at the Sun. Let's get building. We're going to start with our grating, and I want you to remember to handle it from the edges only. And we're going to put some tape on here, some of that black tape I gave you, on the numbered side of the card here. So here's my example. I've got the black tape. It's taped to the numbered side of the card. So what we're going to do is now we're going to take this and our tube and we're going to tape this to the tube. Remember, numbered side out, and tape it to the tube, just like that. Next, we're going to turn the tube over because we're going to work on this side of the tube. And depending on the size of your tube, if you have a long tube like that gift wrap tube, you might want to ask for some help because it's very tall. For a toilet paper tube, you might be able to do this on your own. And what we're going to do is create a slit for light to get into our spectroscope because that's what we're measuring. We're measuring light. So on this side of the tube, we want to take a piece of tape and cover half of the tube like this. All right, so now I have a piece of tape covering half of my tube in the back. You'll notice that the tape is running up and down in relation to the words on the front of my grating. This is pretty important, so make sure you get this part up and down, covering half. Now we're going to create the actual slit, which means I'm going to put a second piece of tape right next to this first one. But I want to leave a gap there, and that gap's going to be about the size of a quarter on its little edge. So you can see here that I've got a gap in between my two pieces of tape. Once you have a gap there, I want you to go ahead and smoosh that tape down and make sure that it's secure on your tube. So I've gone ahead and used another piece of tape. You can see I put it all the way around my spectroscope here. This is the slit end, again, remember? And so now that's it. Your spectroscope is finished. So now we can go ahead and start examining some light sources. So remember, you don't want to point the slit end. This is where the light's going to come in. We don't want to point this directly at the Sun. But if you want to look at the Sun, what you're going to do is you're going to point that end at, you can use the sunlight on the ground, the sunlight on a wall, but just don't point it directly at the Sun. In this case, I'm going to look at the fluorescent light that's here in my office. These are standard T8 fluorescent tubes. That's the long, skinny tube. And you'll see on that spectrum worksheet that's in your kit, you can find the spectrum of that fluorescent tube. Where is it? Fluorescent. The lights with the long tubes. And this is what you should see in your spectroscope. So what you're going to do is you're going to put your eye on this end of the tube, and this end of the tube is going to aim at your light source. Now when you look inside of your tube, you're going to want to make sure that you cup your hand around your eye while you're looking through the tube, just to kind of block out some extra light. And then when I look inside of the tube, I'm going to use my left eye, and I'm going to look toward the right side of the tube. I'm going to aim my eyeball right here. With my left eye, I'm going to aim to the right side of the tube, and I'm going to look in there. And what you should see is a rainbow. So I'm going to show you a picture of that, of what my eye is seeing through there. I'm going to use my camera and show you a picture of that. Same thing, when you look at the sunlight on the wall, you're going to look toward that side. If you are right-handed, you're probably going to look with your right eye. It's one of those weird things. And if you're looking with your right eye, I want you to look at the left side of the tube. So basically your eye is going to go across the tube, and you're going to look up at your light source, except it's the sun. Remember, we're not looking directly at the sun. And you'll be able to see the spectrum of that light that you're looking at in the tube. So I want you to go ahead and experiment with this. I've given you a bunch of things to look at on your spectrum card here. There's the street lights outside your house at night. They're going to be LEDs, depending on where you live. Here on the Big Island, we use a lot of LED lights, but if you're in one of the areas that has not yet been converted, you probably have some what they call low pressure sodium lights, and you'll see that spectrum is completely different from LED lights. If you live by a big park that uses lights at night, those are high pressure sodium lights, and again, the spectrum is going to be different for that. So I want you to go ahead and experiment, play around, and find out what other light sources that you can look at that have different spectra. It's super cool, especially if you can find a neon light. That would be really great. But anyway, I'd really love to hear what you think about this experiment, about this building of this spectroscope. And you can contact me at outreach@keck.hawaii.edu. Once again, I'd love your feedback, and I'd love to see pictures of what your spectroscope looks like. You can go ahead and decorate it with lightning bolts or stickers or anything to make it look really fancy. And impress your friends that you are now an engineer, you have built an instrument, and you're also an astronomer. You have looked at the stars, and you have made determinations of what they're made out of. Anyway, thanks so much for playing along, for stopping by on Astro Day and picking up this kit. And congratulations, you have built an instrument. We'll see you guys later.